All right, so I wanted to show you there were some area problems on some of the problem sets we were doing that were a little trickier, and I just wanted to do a video going over a couple of those examples. So, for example, one kind of problem that you might have seen is you have a hexagon like this, and all you know about it is that it's a regular hexagon, and you know that the perimeter of the whole thing is equal to, um, well, let's not do the perimeter. Let's say that we know that the distance from the center to the edge, I mean, we could have done the perimeter, but let's just say we have the distance from the center to the edge, which we can call the radius. We can put quotes around it because it's not a circle, but we're going to say the radius is equal to 6. And we want to find the area of the whole thing. So if we use the word regular, what that means is we know that all of these little um, lengths are all going to be the same. Regular just means that all the side lengths and all the angles are equal to each other. So now I know that all of these things are 6. I guess I kind of double labeled one of them there. Anyway, 6, 6, 6, 6, 6, 6, 6, all around the side. And so what I'm going to do is find the area by finding the area of one of these triangles and then multiplying it by 6. So if I focus on one of these triangles right here, I know that it goes 6 and 6. I don't know what this length is, but I don't know that I really need it. If I know this angle right here, then I can use the area of my purple piece. So the area of my triangle is going to be 1/2 AB sine of C, the angle C. So we need to figure out what this angle is right there. What I know though is that it's a hexagon, so there's 6 pieces to it. So if I spun all the way around, that'd be 360 degrees. So if I go 360 degrees and I divide it by 6, that's going to give me the angle right there. So now I know that the area of my little triangle is 1/2 times 6 times 6 times sine of 360 divided by 6 turns out to be 60 degrees. Sine of 60 degrees. So now you grab your calculator and we can do, let's see, I'll do the sine part first. So 60 degrees, hit the sine button, times 1/2 times 6 times 6, and end up with the area of one of those little triangles being 15.59. So then, if we wanted to go back and find the area of the whole shape, it's just 6 of those triangles. So the area of the whole shape is just going to be 6 multiplied by 15.59. 6 times 15.59. So the area of the whole shape is 93.54. So just be careful. There's going to be some problems like that. You saw them in your problem sets. You'll see them on your quiz. Um, you could also see a problem where you have something like this, where it's not just the hexagon. Maybe what I actually care about is you got a circle that goes right around the edge of the hexagon. And maybe what I really care about is all of these little slices here along the outside. So the area in between my hexagon and my circle. So what I could do there is I could say the area of that is equal to the sector minus the triangle, because that's going to give you the area in between if I subtract those two pieces. And so the area of the sector, you're going to get that by doing 60 degrees out of 360 degrees multiplied by pi times the radius squared minus the area of a triangle. We got the formula here, or we could just drop in the answer we already figured out there, 15.59. And then if we, let's see, calculate that, I'll calculate it in two different pieces. let's go 60 divided by 360 times pi times 6 times 6. That gives me 18.85. Subtract 15.59. And I get 3.26. There we go. But that's the area of one of those sections. So then the total would be 6 times 3.26. Comes out to be about 19.56. So just be careful. There's probably there's going to be some tricky problems like that. So make sure that you're just using your formulas, cutting the shape up into different pieces that you are familiar with. So thanks for watching. Please comment, ask questions if there's anything I can do.